send in
Yeah.
my driver's license to get a copy of my son's social security card. And I'm like,
Hello.
Hello.
hey, Dr. Musk.
Hello. How is everybody today?
All right.
We're
Got a cat
so
today.
close. Oh, I like it. It looks like a lynx.
That cat looks like it is not happy. It's all
Sarah and I had a coffee chemistry
She's purring.
play date today.
coffee
Yeah?
chemistry.
It was super cute from the pictures.
You
We
gotta
just-
give me
we-
just a second. I just spilled something on my counter. I gotta go get a rag to wipe it up. I'm such a moron.
There you go.
Nah, not a moron.
Was it coffee or was it chemistry?
Do you ever have those times where you do something in slow motion and your body is like so ignorant, and then your brain sees what your body is doing and is like, no. That's
Yeah.
what happened.
Did
Yeah.
it happen? Just
Yeah.
Yeah, we went over the practice test together and we have a question
Oh,
Yeah.
okay.
because I answered it the same way she did.
yeah.
It was number 7, fill in the amazing shortcut formula. So I wrote P1 V1 over N1 T1 equals P2 V2 over N2.
But that's not dilution. It says the amazing shortcut formula for all kinds of dilution math, right?
Oh. okay.
Dilution.
That makes sense.
We have to
Okay.
read.
All right.
There are lots of amazing shortcut formulas, but only one of them has to do with dilution math.
Okay, so then it is the C1
Yes.
V1 equals C2.
Or if you want to write it differently and say C initial and V initial and C final and V final, that's fine also. Like
Okay.
concentration times volume equals concentration times volume. That's your
This is our
I argued
final
with
class.
Kat about that. I was like, no, that's not the shortcut. Like,
Then she got me second guessing, and I'm like,
I was like, no, it's right here in my notes. It says right here in my notes, this is going to be on the final. This is the amazing shortcut on the final.
It will be on the final. Maybe not for you to fill in the formula because it's open book, open note, but you'll have to use it. I promise.
this is our last class together for now, Dr.
For now.
Wait, we don't have any. Oh, yeah, because the exam opens. So then,
Exam opens at 8 o'clock tomorrow morning, right? This is our last time together.
Oh, and Miss Jennifer, I got an A in the class that no one gets an A.
Congratulations.
I got a 90.9 and I don't know how.
Is that the math class you're in right now?
It's the English.
English.
It's a really hard English professor. She's known for being tough.
Tina, boss, Tina.
Mm.
Yeah, so it was very, oh, yeah, but yeah, so,
But it's rewarding to get A's in classes that are hard classes.
well, a lot of people dropped out of that class. It started with like a whole bunch of students, but it definitely dwindled.
My graduate organic chemical synthesis class, I got a B in, and I'm prouder of that B than of any A I've gotten in any other class because the class is like almost impossible. So you work as hard as you can and you get what you get, and that's okay. If you worked hard, you have nothing to be ashamed of.
Unless you get an F.
If you worked hard and did your best and you got an F, then you don't have anything to be ashamed of because what
Yeah.
were you going to do different?
Bing,
Right.
ding,
I
ding,
could
ding.
work as hard as I wanted to right now for a year and put my body through absolute torment. And still at the end of that, I still would not be able to qualify for an NFL roster. And there's nothing shameful about that. Like if I tried as hard as I could and couldn't do it, then that's just not my path, and that's okay.
So is the grading system flawed?
No, because grading doesn't necessarily reward trying, right? Sometimes this class, we can't grade try. We can grade how well you understand the material in the CHEM121 sequence. That's what the grade is supposed to come from. So.
Oh, excuse me, sorry.
What can I help you guys with? I want to help you. Last minute
Well,
stuff that you want to
maybe you could throw us a
Oh, wait, I
question
have
about
another
that
question.
amazing-
Oh, sorry. Sorry. My bad.
No, ask your questions. I like.
Okay, so the part in the practice test where it's talking about definitions,
Yep.
and then one of them says strong acid. Well, strong acid by that name is not listed in the book as like a definition. So I looked it up on lumenlearning.com.
Okay.
And their definition is the strength of acid refers to the ease with which the acid loses a proton. A strong acid ionizes completely in an aqueous solution by losing one proton. That's their
Exactly.
definition.
Exactly.
Okay.
And that's the definition that we talked about in class. So
Okay.
strong acids are acids that dissociate completely
Right.
in water, right? They lose an H plus to water. That's a strong acid.
Okay, so like if a question like that were to be on the test, that would be an acceptable answer.
Sure.
Okay. Do I need to put that like I got it from lumenlearning.com way before? Like,
No.
okay.
So my question is the P1, V1, P2, V2, N1, T2 to N1, that equation you gave us, that awesome equation that I put on this test in the wrong spot.
That's the gas.
Could you maybe
laws.
give us an example to how we would?
Use that? Sure. Yeah, I'll give you a problem
Yes.
in just a second. So Sarah, I'm also looking in chapter 8 to see where we talk about strong acids.
That was actually in chapter 9.
No. It's also in chapter 8, which is
Oh, it's
why
at
we
the
covered
it's at the end then. It's at the end of chapter 8.
Are you sure about that?
I just looked at the book, but now the book is now under my laptop, so I can't pull it out. I think it's at the end. Is that wrong?
Sarah, I definitely came home and took a nap.
I didn't, I worked. I think so. It's page, it was like page 302, 306, 312 in the book. So I think 302 is going to be in chapter
No,
8.
there's something strange. So in section 8.2 on page 265. Where we talk about electrolytes for the first time, there's a table that, so I think that chapter 8 doesn't do a great job of talking about why strong acids are strong electrolytes. It just says that they are, which is weird because you don't even really learn what a strong acid in terms of a definition is until chapter 9. So I filled in the blanks when we talked through chapter 8 to talk about why strong acids like HCl are strong electrolytes. In order to understand why they're strong electrolytes, you have to understand what a strong acid is in the first place. So I think I gave you that definition, and I don't think it's anywhere in chapter 8 at all, but it really belongs in chapter 8, because without that definition, you don't understand why strong acids are good electrolytes. Does that make sense?
Yes. I will look back.
And I will say, like, I wouldn't spend tons and tons and tons of time memorizing definitions, because with an open book, open note test, I'm not likely to give you that many definitions to fill in, because like you could just read the definition in the book and put it in your own words and get the credit. I want you to do a little bit better thinking than that for the exam.
Yeah, well, that's what I did. I just got them from the book. So
yeah.
But
so anyway, the concept of a strong acid really makes its first appearance in chapter 8, and they should talk about it then, but they don't, which is why I did.
Okay.
Okay. Okay, now Kat, you wanted another example of how to use the ideal gas law. So let's do an example problem, okay? What the? I think my cat's unplugged my overhead projector because I had it plugged.
They're like, enough work for you today, Dad. It's
What happened? No, like I know exactly where that plug-in was, and it was plugged in last time I was in here, and it's not now. Okay. They do the weirdest things. So normally, if I can hunt a little bit, like if they've unplugged something, there are little tooth marks where you can see that they've like pulled on a cord. They don't really chew on cords, which is really good, but
This is how I woke up today with my cat literally trying to suffocate me. Dr. Moeller.
I love that.
Like, he's just comfy, just purring along, and I'm like, okay, that's fine. Cats are weird. Damien.
Got weird. These are weird kitties. Okay.
So the reason I write down this equation is because this problem has to do with a gas that is undergoing some sort of change in its conditions, right? We're changing the temperature at which the gas is stored at. So from context, what can we also tell is not happening in this problem? What's not
Number of
changing?
moles isn't changing.
Number of moles isn't changing. What else isn't changing?
Volume.
Yeah, or else the problem would have said something about expansion or contraction. So we know the only variables that are changing are pressure and temperature. So because that's true, V1 and V2 are the same thing, and we can cancel them out. N1 and N2 are the same thing here. We can cancel them out. So let's substitute in what we know and solve for what we don't. Our initial pressure is 28 PSI. Notice I put kind of a weird pressure unit, one we don't use very often in this problem. And it's because the great thing about using P1 V1 over N1 T1 equals P2 V2 over N2 T2, if we know the units for our initial pressure, the final pressure should be in the same units. So even though we're not familiar with using PSI as a pressure unit, we can solve for the new pressure in PSI, and that's fine because we know what the old pressure unit is. The new pressure is going to be in the same units. Our initial temperature is 17.7 degrees Celsius. So I'm converting that to a Kelvin temperature. So I added 273.15 Kelvin because we had a temperature all the way down to the 10th of a degree. I just want to make sure that I'm not messing up my significant figures by not keeping enough. So if you want to do your conversion to Kelvin and not lose any sig figs, add 273.15 to your Celsius temperature instead of just 273. Yeah, on an exam, if you added 273 instead, no big deal. All right, it's going to be a very small difference anyway. So our new pressure is what we're trying to solve for. And our new temperature is 43.0 degrees Celsius, so 43 plus 273.
316.15.
Thank you very much. 316.15. And then we cross multiply to isolate P2.
This is much easier than what Alex showed. Okay.
Well, in this particular case, the only variables that were changing were pressure and volume. We could have a case where all the variables were changing, and this equation will still work fine for that. We just have more stuff to plug into the equation then. Does that make sense, Kat?
Yeah, it really does. This is much nicer, cleaner, kind of.
It is. Instead of, so what we would have to do to solve this problem without this form of the ideal gas law is figure out which variables were changing and then figure out what law we would use. And it would be a Montan's law here, but who cares about that? We don't need the individual laws when all of them are included in this statement, right? That's why I like this form of the ideal gas law anytime there's changing conditions. And I think the other really cool thing that this problem teaches us is that it works with any pressure units, right? And in this case, do we even need to know what the value of R is when our pressure is in PSI? Doesn't matter, right? We're never using R here, so we don't have to look up the value of R, the gas constant, when our pressure units are in PSI, as long as we know that our new pressure is going to be in the same units as the old pressure.
That's much cleaner. Wow. Okay, thank you. I have to start now.
Other things that you guys want a little bit more practice with?
Maybe give us a really, really hard one.
Or not.
I don't think there are going to be any impossibly hard kinds of questions on the third exam. If you've looked at the free response questions for the practice exam 3, there's not going to be anything that comes out of thin air that's like 10 times more difficult than those. It's just not going to happen.
Well, so I know you say you don't like to trick us, but sometimes you do put in tricky little questions that kind of like
Trick,
molecules instead of
I
atoms.
guess we'll have to agree to disagree on what the meaning of trick is. So I don't like to trick students. What I do like to do is write questions in a way so that they have to have a very clear understanding of the theory in order to answer them correctly. And because of that, they can be particular sometimes, right?
Okay. Yeah, that's not
So
trick.
a
Okay.
good example of that, I think, is on exam 1, where there were those 5 questions, A through E, that were in at the very beginning of the free response that made you do significant figures calculations. You only could get those right if you knew and applied the rules, right? So
Yeah.
that's the only way that I can ensure that you have done the work to understand how to use significant figures correctly, is if I write questions that you only get right if you apply the rules the right way. Does that make sense?
Yeah, okay,
So,
so you're right,
Is
they're
that
not really tricky. It's just-
Yes,
yeah.
but it's only tricky because it has to be to discern whether you've learned what you're supposed to learn.
Okay. But that's not really tricky, like you're not trying to fail something.
No, I'm not trying to
Okay.
fail anybody.
So what I don't see in my, when I go to my, I know this is out of the contest. When I go to my grades, I don't see the exam 3 include, you know, like it doesn't exist.
Exam 3,
Yes.
that's because it hasn't been published yet, Luz.
I mean, but it not even in grades, it's not going to be there just for.
No,
I
it'll be
can-
there, I promise. Yeah, it'll be there.
Okay, okay. Also about my lab number 8. I
Lab
forgot
number
to
8 is still being graded.
No, it's fine. I just my printer didn't work up, so I just write everything in hand and I scan it. So just for let you know.
That's fine. I can still grade handwritten labs. Lots of people turn in handwritten labs and even handwritten exams where they're just taking the exam on notebook paper like this. As long as you number your questions carefully and I know what you're answering, no big deal. I can grade that. Okay,
Okay.
Kat, question.
No, I was just saying, I'm one of those people who hand in handwritten.
Yeah,
all the
handwritten
time,
stuff
too.
is fine. As a
Yeah, I
matter
do
of fact,
handwritten stuff too.
It takes less time to handwrite probably than to spend your time like printing a copy of the exam. A lot of people
And you
like
spend
to
less money on ink.
and you spend less money on ink. If you really like working on an exam just like you would in a classroom setting, print it and then
Yeah, I
you can
need
work
it.
on your. Yeah,
I
that's
know I
totally
need-
fine.
Okay.
But
That's
if you don't care and you want to just work on loose leaf paper, as long as you number your problems so that I know what you're answering, I can grade that. All right. So either way is completely fine. One thing that I will dissuade people from doing is like actually typing things and turning them in. For some of the labs, it's fine. But sometimes like there are formatting kinds of things like using subscripts and formulas, drawing, things like that that are kind of hard to do with just typing. So I would prefer students either print and fill out something or just do it on loose leaf paper and then scan it and turn it in. Like take pictures and, you know, turn the scan of the PDF in. Jules, question.
Catalina was raising her hand. I only did the
Catalina,
thing, so-
question.
Yes, could you please do one more problem with equilibrium?
Equilibrium, sure. So do you mean like using equilibrium constants or do you mean like Le Chatelier's principle? We can do either or both.
Writing the equation and knowing where products or where things shift.
Okay, so let's do one of each of them. All right. Let's say.
You didn't like it, Kat?
Stars is having a sale on cherries and I was wondering if they were like sweet or tart, so. Mhm. Mhm, mhm.
So I'm giving you all the information that I can because we're going to use this question for a couple of things. All right. We're going to do a little bit of just basic recall on equilibrium stuff. All right. So for A, I would like you to write the general expression for the equilibrium constant here. So KEQ equals what for this reaction in particular? And then what does the value of KEQ tell us about this reaction at equilibrium? All right, we know that the value of KEQ is 385. What does that tell us about this reaction?
A lot of products.
Yes, that's true. But I was just sort of, I wasn't asking for you for the answer right now, but that is the answer to this question. So the value of K being a big number tells us that we have a lot more products than we have reactants at equilibrium. So that is correct. Thank you, Jules. Remember that KEQ in general is concentrations of products over concentrations of reactants. So remember also that any coefficients from the balanced equation become exponents in the equilibrium constant. So our products, NH2Cl, we've got two of those, so our NH2Cl concentration is squared. We only have one H2, so our H2 concentration is to the first power. Then in the reactants, Cl2 is to the first power, and NH3 is squared.
And that, and the keg is gases only, correct?
Or concentrations of aqueous things.
So gases and aqueous only, like ignore
Not
solids.
solids, not liquids. Yes.
I'm just verifying what's in my notes.
Good. So if I want to force this reaction as far to the right as possible, should I increase the temperature or should I decrease the temperature?
To the right, so towards the reactor.
Decrease.
Ah,
Wait, hold on. This is endothermic, so
let me think there.
It is an endothermic reaction. That's what delta H tells us. Being positive, that's an endothermic reaction. So does that mean
the
heat is a reactant? Or heat?
Oh, so you want to increase then?
So if heat is a reactant, what does that mean about this reaction if we increase the temperature? Will we shift to the right or to the left if we increase the temperature of this reaction?
Left.
No, you still want to
No.
decrease. You do want to decrease.
If we decrease the temperature of the reaction, Le Chatelier's principle tells us the reaction will respond by increasing its temperature, right?
Mhm.
So how would this reaction increase its temperature?
By not producing as much.
It would shift to the left if it
Yeah.
needed to increase its temperature, right? So if we wanted to shift the reaction to the left, we would do that by lowering the temperature because the reaction would respond by making more heat. If we wanted to shift the reaction to the right, we would do that by increasing temperature. And increasing the temperature would shift the reaction to the right because then we would get rid of that extra heat by making more products. So this is a great question because it's about more than just thinking through how the reaction is going to respond. It's about us anticipating how the reaction is going to respond and using that to push the reaction in one way or the other, right? So if we wanted to push this reaction to the right, the way to do that is by putting more heat in because the reaction will respond by getting rid of heat by making more products. Does that make sense to everybody?
Yes.
I did a bit of a sloppy job writing this question, and I don't mean my handwriting. So if we're talking about which direction the reaction is going to shift, our assumption has to be that the reaction's already at equilibrium when we mess it up. All right. So if the reaction's at equilibrium, what will happen? Which direction will the reaction shift if we remove some of the NH2Cl from the reaction container?
It would shift to the right.
Kat, can you explain why? And use
So
Le
if you-
Chatelier's principle.
So if you remove NH2Cl, sorry, my eyes went blurry for a minute.
Good.
So if you would remove it, so you're removing it from the equilibrium, it's going to counteract by trying to balance it out by adding more. It's going to shift over there and going to be like, no, we need that. Like, so.
Because it's
That is
being
exactly
disturbed.
right. Whatever we do to the reaction is going to try and do the opposite. Kat, I could not have explained that any better myself, right? So if we take some out, the reaction is going to try and make more. So it shifts to the right because that's the side on which we make more NH2Cl to replace what we took out. Very good. Okay, which direction is the reaction going to shift if we decrease the pressure in the container?
Also
Yeah,
to
somebody
the
else.
right.
No, it's gonna shift to the left if it's
No, it's to the
decreased.
right because the Le Chatelier's principle. If the pressure on the thing is decreased, then the reaction itself is going to try and increase it.
Okay, so if the reaction is going to try and increase the pressure, which I completely agree with you, that is the statement of Le Chatelier's principle for this reaction, right? If we decrease the pressure, the reaction will respond to that perturbation, that disturbance, by trying to do the opposite, trying to increase the pressure. So which side can this reaction shift to increase its pressure?
I assumed to the right because it would make more products.
Wait a second. I didn't see the H2.
It will be the left
Left.
for, yeah, the left so the right can go
Where does
up.
pressure come from in the container?
Amount of
The
moles.
moles.
From the
Moles of gas, right? More moles of gas means more collisions, means more pressure.
But they have
It-
equal number of moles on each side.
Yeah,
There are 3 moles of gases on in the reactant side, and there are 3 moles of gases in the product
so it
side.
won't shift.
It won't shift.
What's
see,
it?
that was a trick.
Yeah, it
It's
wasn't
not
a trick.
if you
It's not a
understand the
trick.
principle.
I didn't see the H2 when I was working on that for some reason.
It's not a trick, all right? So it's not
Because
a
it's on
trick
the line.
because if you look at this equation and you know where the pressure comes from, you know that there's nothing that this reaction can do to change its pressure, right? It cannot
You
shift
know-
to a side with more or less moles of gas. So we're stuck in this case.
You know what showed all the answers? That we are not ready.
I'm ready.
Don't do this to us.
We're ready, Luz. We're ready. We can do
We're
it.
ready. Luz, you got this.
You can do it, Luz.
I
I'm
agree
pretty
with that.
sure.
I completely agree with that. Like,
We can do it.
you know what you're talking about.
We can do it. Probably.
Just order pizza and do it with pizza.
Just like if there's a solid in the reaction, if that solid is removed, there is no effect because it's only the gas and, oh, he's probably writing that right now. Never mind. I
Just-
just saw the
I'm
solid.
writing another problem for fun.
Yeah, please, more of this.
More of this. I love you, Luz. I agree.
More of this.
The delta H for this reaction is certainly negative.
Exo.
It is an exothermic reaction. Matter of fact, if you tried to do this reaction at room temperature, it wouldn't be very good.
Oh.
What's weird is that the small amount of oxygen in the atmosphere, actually sulfur is pretty shelf stable with, like, if you just leave it out in the air, you can buy sulfur at hardware stores. They're called sulfur flowers. It's like pressed yellow sulfur. That doesn't just like blow up in air or anything, but if you have it around pure oxygen, then you're asking for some trouble.
Yay. No.
Pure oxygen is actually an incredibly, believe it or not, oxygen is a good oxidizing agent. So pure O2 is one of the best oxidizing agents. If you get oxygen really cold enough to condense it into a liquid, oxygen has this beautiful like pastel blue appearance in its liquid form.
Yeah, it's
actually
really pretty.
It's really pretty and really, really dangerous because it's such a good oxidizing agent that almost any organic chemical, so like any oils or things that come into contact with it, it'll start a fire or blow up. Yeah, so liquid oxygen is something that organic chemists really have to worry about a lot because we run reactions at cold enough temperatures where liquid oxygen can condense and can react with things that we have in our containers and cause an explosion. So that's something that if you're ever doing cold reactions, you have to worry about condensing liquid oxygen.
Basically, pretty things in chemistry can be very dangerous.
They can, very often. Chlorine gas is pretty. It's got kind of a like diffuse green appearance to it, but it doesn't smell very good at all.
Oh shoot, that's
So
wrong.
hopefully your KEQ, you have this, our SO3 concentration squared divided by our O2 concentration cubed. Why did I leave sulfur out of the KEQ?
Because it's a
It's
solid.
a solid.
It's a solid. Yep, solids and liquids.
I
don't
started
show
writing
up.
that down and then I'm like, oh shoot, I
Yep,
shouldn't
I
have
gave an
written
example
that down.
of that just so that I couldn't have someone claim that I was being tricky on the exam if I put a solid or liquid in. All right,
Well,
we don't want
What was
tricky.
the question? I'm sorry, my brain is so slow today. What was the question?
Oh, the question was, what's the KEQ for the reaction? So there's the KEQ. And now let's do a few examples with Le Chatelier's principle.
Yes.
I learned to love Le Chatelier, by the way. Now that I understand him a little bit more.
It's not easy. This took me a really long time to get good at. You guys think that I just like instinctively understand chemistry, and a lot of chemistry I do understand instinctively now because I spent the last 20 years developing the instinct. That doesn't just happen naturally. It happens by brute force. So if you're not inspired by your study of chemistry, like, don't worry about it. It's not something that's natural for most people. We all have to work hard at this.
What if we are inspired, but our brain is not like?
It takes a long time to get used to. There are very few people that take to chemistry naturally. I wasn't one of them, all right, at all. All right,
Okay.
which
You're an
direction?
I
What's
know.
What did you say, Sarah?
I said that Kat's an anomaly.
Cat has an anomalous electron configuration.
Yeah, she does.
Okay, I love that.
All right, which direction will this reaction at equilibrium shift if
Dot, dot, dot.
the temperature is increased? If we add more sulfur to the container? If we add more SO3 gas to the container? If we increase the pressure? All right, take a second. Don't answer any of these out loud. All right, make your predictions. For each one of these, which direction will the reaction shift if it's at equilibrium? And then we mess it up each of these ways.
Yes, she was.
Thank you.
Bye, Freya. How much I want to see rejects in my room.
Okay,
You doing what?
so you got a 50-50 chance. Temperature is increased. Which direction's the reaction going to shift?
Now do we
To the
shout out?
right.
Yeah, shout.
Left.
How many
I'm
people
going to
think
the
left?
right.
Oh,
I'm
Jules
going to
says
the
right.
Wait, are you saying left? How many people think left?
No, right. I'm going to the right.
Nope.
All right, we need to think through this because we don't have a unified opinion. I hope
Oh,
we,
wait,
I
is this,
hope
you
we would
said,
have a
wait, what
unified
did you
opinion.
say? Temperature?
Yeah,
Temperature increase?
yep. I've heard both left and right.
Left.
I say left.
Left.
The correct answer is
I'm scared now.
Left.
it's to the left. So let's review why, all right, for all of you righties out there. Not that being a righty is bad, but it is in this case, okay? So if our temperature is increased, the reaction's going to respond by trying to decrease its temperature, right? So this is a reaction with a negative delta H, an exothermic reaction. So we know that heat is a product of this reaction. If we increase the temperature, the reaction can get rid of extra heat. It can decrease its temperature by shifting to the left to get rid of that heat that is a product of a reaction. We can use up that product by shifting left to make more reactants. So that's why we shift to the left here, to get rid of that extra heat that is a product of this reaction. All right, so 50-50 chance. Which direction do we shift if sulfur is added into the container?
None.
Nowhere.
Very good. This was actually a trick. It wasn't a trick until I said 50-50 chance, because it's not actually a 50-50 chance. It's a 1 in 3 chance in this case. And the reason why sulfur doesn't affect the equilibrium at all, why?
Because it's a solid.
It's a solid. Because it's a solid, it doesn't show up anywhere in the equilibrium expression, which means that if we add more or take some sulfur out, it's not changing the products or reactants that are in the equilibrium expression, which means it doesn't affect the equilibrium. Sulfur has to be in there to make the reaction work, but the exact amount of it that we have does not affect the equilibrium. Very good. That was a hard question.
You're
Which
on fire,
direction?
Sarah.
That's Sarah Ding.
It's called lots of coffee.
I still have some of
I
mine
need some
too.
of that.
Yep. And I'm going to drink some more of it tonight while I'm writing that third exam for you guys. I've got a couple of really fun questions in mind.
Fun.
Oh,
Fun
oh
means he's
my
gonna
God.
stick a solid in there, guys. That's what fun means.
I get to go to the neurologist tomorrow.
Oh, lovely. Neurology visits are great. I've had a few of those.
I
I've
miss
probably
the
had
neurology.
more.
Well, I hope that everything is okay.
I think I've probably had more neurology appointments.
I don't want to say how many neurology appointments I have, because then you guys might think that my brain wasn't in good enough shape to teach you anymore.
I've had none, but I've been to the ER a lot.
I've been there a lot too.
It's not a contest, guys.
No,
Not a
it's not a
contest.
contest. Okay, sulfur, SO3 gas is added into the container. Which direction is the reaction going to shift? Remember,
Left,
whenever you get
left.
stuck, state Le Chatelier's principle to help you. If the disturbance is that more SO3 is put into the container, the reaction's going to try and do the opposite. It's going to try and get rid of SO3. How can this reaction get rid of SO3? It can get rid of it by shifting to the left to turn it back into reactants.
Everything you own now plugs to the left in the club. I'm in a good mood today. I apologize.
I keep trying to speak and I keep forgetting I'm on mute. Isn't that impossible if one of the reactants is a solid?
No.
No.
No, we can make more sulfur. There's nothing wrong with us shifting to the left and making more sulfur. What about if we increase
What?
the pressure?
Right.
So
Is it
state
to
Le
the right?
Chatelier's principle in your head. If the
Okay,
to
reaction
the
is
left.
disturbed by an increase in pressure, the reaction will respond by trying to decrease the pressure. So which direction can this reaction shift to decrease its pressure?
To the right.
Left.
Right.
Left.
To the,
You ignore
To the
something,
right.
Sarah.
to,
Right.
The reaction can decrease its pressure by shifting to the side that has less moles of gas present.
And only gas.
So when I look on the left-hand side of this equation, I see 3 moles of gas. Those 2 moles of gas don't count. Those 3 moles of O2 are 3 moles of gas. On the right, I see only 2 moles of gas. Those 2 moles of SO3. So shifting to the right is going to decrease pressure because it is decreasing the number of moles of gas in
What
the
if you
reaction.
decrease the pressure?
Yep, it's going to
So then I'd like to change my final answer to the right, please.
Good.
For 80 million. Thank you very much.
Yeah, there will be a Le Chatelier's principle question like this on the exam. Guarantee it.
thank
Great.
I went over this
you.
with my tutor
You already
today.
know that no.
You already know it, so it should be an automatic 10 points for you.
Oh my
10
god.
points. Oh my gosh.
How many
There's
points is
a
this?
lot involved with interpreting a question like this. It's a 10-point question all day.
And the
How
curve
many
is
te-
automatic,
How many
right?
points are on this test? I just
Somewhere
want to
between
know.
90 and 100 probably. All right.
Okay.
I should say like between 80 and 120 just to, because I haven't finished writing it yet, but it'll be something close to 100.
Okay.
Oh, and the curve's automatic, right?
It's automatic.
I'm not banking
Okay.
on it. I'm just in case.
Dr. Mas,
Yes.
sorry, I just want to clarify. So whichever side has the higher number of moles, that means that's where the pressure is
The pressure will be greatest on that side.
on that side.
Shifting depends on whether the disturbance is a decrease in pressure or an increase in pressure. So if we disturb the reaction by decreasing the pressure, the reaction would respond by trying to increase pressure. So in this case, if we decrease the pressure, the reaction would respond by shifting to the left to increase its pressure. Does that make sense?
Mm-hmm.
Yes. Thank you.
Mhm.
I apologize. I'm so sorry.
Yeah, we're all tired at this point. There's no harm in yawning.
I've been sleeping like straight garbage this week with all my finals.
I honestly don't even mind, like, well, do I mind? It's a little irritating when students fall asleep in class, like in person. And that's more of just like a pride hit than anything else, but everybody has so many things going on. That's one of those things that I feel different about now that I'm a professor than I did when I was a student. When I was a student, I would fall asleep in classes sometimes. It wasn't because I wasn't prepared, it was because I was serially overcommitted. So like looking back, was that a really bad thing to do in terms of like a body language thing for showing the professors that I was interested? Yeah, it was stupid, but I did it. So anyway, I didn't feel bad about it then because I rationalized it like I'm getting A's on my tests. How can you be mad at me? But yeah, I don't like to talk to people who are asleep in class. So
It helps. I've never slept in your class.
no, if you slept in my class, like honestly, and I honestly have not had very many students that were sleepers in my classes who also were people that got A's on everything. So I haven't had that like specific case. Not that I got all A's in all my classes in undergrad. That's not true. All right, let's be fair. But anyway, it's definitely something that I look upon less favorably than I did when I was a student. So there's some sort of a philosophical term for that, like personal morality versus, I don't know, like what you consider to be bad for you to do as opposed to what you consider bad for other people to do. And there's lots of philosophy books that are written about that conundrum. We tend to judge other people more harshly than we judge ourselves.
Yes.
Speak for yourself.
Well, if you judge yourself more harshly than other people, that's great. I love the idea of giving grace where you can. Any last questions? We're at about an hour right now.
Any last words is what he's really asking.
Oh, stop. No, if you understand the concepts as they're presented on that practice exam, if you have gone back through the chapter videos and you have done your Alex homework, you should have nothing to worry about. There's not going to be a question that comes out of thin air to surprise you over material that you didn't understand and we've never done practice question on. All right, that's not the way this class is, or at least I endeavor to make it not that way as much as possible.
All right, I just feel a little less prepared for this one than I was the others for some reason, which I'm
Well, you still
probably
have
not.
about a
but-
day left, so get to it.
Yeah.
No, I'm doing it first thing in the morning because
Okay. Yeah, and you don't
I
have
have
to
a
take the
whole-
exam tomorrow. You have all the way until the end of Friday night to take it, right? So you got 2
Okay.
days. If you need the extra day, if you need tomorrow to study, then take it, right? I'm giving you a 2-day window to take the exam in. So use whatever time you need. If you're done and ready and you want to get it over with at 8 o'clock in the morning tomorrow, do that. So I'm excited to see how everything turns out for you guys, and I'm wishing you the best.
thanks, Dr. Musk.
Of course.
Thank
And
you.
thanks for going over equilibrium. Actually, that helped me a lot.
Sure. I kind of figured that Le Chatelier's principle might come up today because yesterday we really didn't touch on it. And I thought, you know, that's a biggie, and it's also one of
I
the,
asked you about it and we kind of
did we get sidetracked? I'm glad we came back to it, Olivia, because yeah, I knew that somebody needed help with that.
We kind of sort of went on it and then got sidetracked.
It happens.
Sidetrack this class? Never.
So I will be switching over to my Zoom office to help anybody with whatever you need help with.
I'll be there.
So
Me
Yeah,
too.
it's the last days. All right, so study hard and like all the things about making sure you like have a meal and get enough sleep before you take the exam. Like make sure you're attending to your mental health because finals week is very stressful. So do your best to make sure you're in peak mental condition when you come in to take the exam, if at all possible. All right. If you have any last minute questions, then I mean, I'll be available tomorrow and Friday, but more than anything, just if students have something go haywire with the exam, I should
No,
be
but-
available to help. All right.
Here's a suggestion. When I was in grad school, they used to do massages during finals week for the students. So they should consider doing that here.
We have had at when we had in-person like celebrations at the Whidbey Island campus, they would have a massage table and like hire a massage therapist for the day and give everybody 10-minute massages. It was the best thing.
Yeah. And it was during finals week, right? Was
Yeah.
it?
Absolutely.
I
Perfect.
could use a massage.
Yeah, you and me both.
When's
Especially
the,
since
when's
I was
the-
painting ceilings yesterday. So I've been doing a lot of ceiling painting over the last like few days, which means that my shoulders are wrecked right now.
We're playing Beat Saber for 2 hours.
I don't even know.
when's the pizza party?
It's a virtual reality. You play along with the song that plays, and then you slice sabers into blocks.
Sounds lovely.
It's so good.
Jules,
No,
All right.
Jules is not here.
I am going to peace out then, and I'll hand control of the meeting over to Jules, and Jennifer is switching over for a review session in her office hours. And if you guys have any last minute questions.
But I'm going to meet Ms. Lawson in her
Actually,
classroom.
I can
so-
stay here tonight because I don't have regularly scheduled Zoom hours, so I can just stay here if you want.
Oh,
Okay, well, I'll just
Okay.
hand the meeting off to you then.
okay.
Okay.
All right.
Okay.
Bye.
Bye.
Until winter time.
Until winter time.
Unless I
Once we're
see you on
back on
campus.
campus, please come by my office and say hi so I can meet
Well,
some of you in person.
To be honest, you owe me a sticker for the last exam.
Yeah, if you get a 90 or better on one of your exams in this class and you didn't get a sticker, come on by and I'll let you pick a sticker out of my sticker stock.
If I
I'm
got
getting a
100,
sticker
do
for the
I get
final.
2?
Get a sticker for the third exam. Yeah.
If I got, the 100 on the second, do I get 2?
There aren't no 2 sticker exams.
What about a sticker for try?
I at least
I
got
like
one.
that.
I'm
a
aiming
sticker
for
for
2
trying.
for the
I
second
like
one.
that.
All right. I'm
I like
out. You guys
Liz's
have
request a sticker for trying. I like that. I want a
Yeah.
sticker
trying
for
stickers.
trying.
No, I got to keep the stickers just for the 90 or better raw scores. So, all
You
right.
should get a second box of trying
I'm still going
stickers.
to try to get an A, so I'm gonna try.
Do your
Okay.
best. Yeah, that's all you can do, right? And you don't have to you don't have to get an A on any of the exams to get an A in the class. And if you don't get an A in the class and you've turned in all your work and you've tried as hard as you can, you got nothing to be ashamed of in that, right? So
Yeah.
I'm proud of everybody that's doing everything that they can to end up in a good place in the class, right? And if you're not, then that's the only thing that
Shame on you. If you're not, shame on you.
I don't want to shame students because there's, life gets in the way of lots of us performing our best.
Yeah.
So what if the
Yeah, yeah.
student's not doing their best because there's a lot of terrible stuff happening to them? Of course, that's not a shame on them. It's just life gets in the way sometimes, right?
Or
But
you've been moving for a month.
you've been moving for a month, right? So yeah, you wonder why those last grades aren't into the grade book yet? Yeah, that's because as soon as recitation's done, then like last night I was over at the new place painting until like 11:30. So it just,
Yeah, he's doing his best under the conditions.
So you never know what kind of darkness someone is going through. Always
That's
be
right.
their light.
so we should extend grace as much as we possibly can, right?
Nespresso?
Yeah.
All right, everybody have a lovely evening, and I'm available via text if something goes wrong with the exam release tomorrow. So come see me when we're back on campus. All right, I can't wait to see you in person, and
I'll see you in the fall for the 160 whatever.
161 series is going to be awesome. I can't wait. All right, have a good
Okay.
night, everybody.